Energy. Energy. Energy makes things happen. Like lighting this bulb, for instance. Energy can never be created or destroyed, just transferred into different forms. Here, electrical energy is being transferred into light energy and heat energy. Let's say you use the stored energy in your leg muscles to kick this ball. Nice. Your kick transferred energy to the ball and set it moving. We call movement energy kinetic energy. When it hits the wall, the ball's kinetic energy gets transferred again, this time into sound energy. Let's see what happens to kinetic energy here. Rub the stick over the block. That was fast. Kinetic energy was transferred again, this time into thermal energy. It got hot enough to light the fire. We've got some light energy here too, given out by the flame. We can use the flame to heat this pan of water. It's important to remember that heat and temperature are not the same thing. Temperature is how hot or cold something is. We measure temperature in degrees Celsius. Heat, on the other hand, is the amount of thermal energy something has. We measure heat and thermal energy in joules. So let's look closer at thermal energy and the difference between heat and temperature. What do you think? Yep, that's right. The larger pan takes longer to boil. Because there's a lot more water, you need to put in a lot more thermal energy to raise its temperature to boiling point. This is a lovely hot cup of tea. It has a high temperature. This swimming pool is not as hot as that, of course. Because it's cooler, you might think it has less thermal energy. But no, because the swimming pool contains a lot more water, there is more thermal energy contained in it than in the cup of tea. Thermal energy can be transferred in 3 different ways: conduction, convection, or radiation. Let's look at conduction. When we heat a substance, we're actually transferring thermal energy as kinetic energy. See how the particles start vibrating? As they vibrate faster and faster, they begin bumping into each other more and more and more. That's how the thermal energy is transferred, from the hot bits to the cold bits. And that's how heat travels up into the handle of a teaspoon. It's also because metal is a good conductor of heat. But the mug handle is a good insulator. Heat doesn't flow through it easily, and so it doesn't burn our fingers. Handy. Next, we'll look at convection. Convection is all about the way thermal energy is transferred between the freely moving particles in liquids and gases. This heater works by convection. Click and hold down your mouse on the hoop to blow some bubbles. What you can see here are convection currents. They show the way thermal energy is transferred around the room. The air near the heater expands and rises as it is heated. It cools as it reaches the top and flows back down, where it starts all over again. That's convection. The third way thermal energy can be transferred is by radiation. Every warm or hot object sends out infrared radiation. We feel this as heat, so the hotter something is, the more energy it's transferring as radiation. The sun is very, very, very hot. It gives off loads of heat radiation. Drag this asteroid closer to see what radiation can do. The asteroid is getting hotter and hotter. There is no air in space. The thermal energy definitely isn't being transferred by convection or conduction. It's just pure radiation. Never mind. There are plenty more asteroids in the universe. Let's have a quick refresh. Energy cannot be created or destroyed. It can only be stored or transferred. Temperature is measured in degrees Celsius. Heat energy, thermal energy, is measured in joules. Conduction transfers thermal energy from hot bits to cold bits of a material, as vibrating particles bump into each other. Convection happens in gases and liquids when thermal energy is transferred by freely moving particles. All objects radiate heat energy. Heat radiation is transferred without involving particles. That means energy can even be transferred through a vacuum. It's time for a test. Question 1. What can energy never be? Question 2. What do we call movement energy? Question 3. What is heat? A. How hot or cold something is. B. The amount of thermal energy. Question 4. All objects radiate heat energy. Heat radiation is... It's time for a test. Question 1. Question 2. Question 3. Question 4. Which ways to transfer thermal energy rely on moving particles of solids, liquids, and gases? Question 5. Energy is transferred from a personal audio player as... Question 6. What is the unit of measurement for thermal energy? Full marks! Very impressive!